Miami, depois pra Dallas.
Ah!
members, this is the final go-no-go poll for operations. Raptor 1, let's go. Raptor 2, yes. Stage 1, go. Stage 2, go. Flight directors, go for launch.
Hard startup. Good afternoon and welcome to the 8th flight test of Starship. What a gorgeous view there on your screen from Starbase, Texas. It is currently 5:05 p.m. Central Time here, and we are looking forward to tonight's launch of the world's most powerful rocket. I'm Kate Tice, Senior Quality Systems Engineering Manager here at SpaceX.
And I'm Dan Hewitt with SpaceX Communications. Welcome to our first ever broadcast from Starbase's new Star Factory building. I've been waiting a while to say that. Super excited. We are just a little over 39 minutes.
Behind us. Now, just over 1 month ago, we saw the second ever tower catch of the Super Heavy booster there at that pad. And that was also the first ever flight of the next generation of ship, which successfully lit all 6 Raptor engines and flew for several minutes before contact was lost.
That's right. We completed our investigation following that mission, made a number of hardware operational changes for today's flight. We're going to detail all of those in just a few minutes. Important to remember, though, progress in a developmental program like this one, it's not always linear. There's no comparison, though, for putting that flight hardware in a flight environment to learn as fast as possible. And as always, primary payload for Starship Flight Test campaign is data.
The objectives for today's flight will look very similar to Flight 7. We're planning to deploy simulated Starlink satellites and fly a range of experiments. We've moved a number of tiles from ship. We've removed a number of tiles from the ship for reentry testing. We will also intentionally be stressing the flaps during reentry so we can test the limits of ship before we get ready to attempt future ship catches. So lots of new testing happening today, and as always, excitement is definitely guaranteed.
And just checking on things at the pad real quick as we're under 38 minutes away. We are tracking to 5:45 p.m. Central Time liftoff. We've got a window all the way to 6:30 p.m. We have started prop load. You'll start to see those frost lines building up on both Super Heavy and Starship. We're not tracking any technical issues, any range issues, any weather issues from a launch at that 5:45 p.m. mark. So we are loading prop on the vehicles, looking good for a launch in just a little over 37 minutes. Now, let's meet today's vehicle on the pad. It's the world's biggest rocket, Starship.
Yeah, you see it there on your screen, but to get an even better sense of how big Starship is, let's start with the average size human, which is about 2 meters high, or a little over 6 feet. Towering over our human is the length of the Millennium Falcon, which comes in at 35 meters. Our Falcon 9 rocket, which is has the payload fairing attached, is double the height of the Millennium Falcon at 70 meters. And twice nearly the size of that is the fully stacked Starship, just over 123 meters tall. The ship is about 52 meters tall, and the Super Heavy booster alone stands at about 71 meters. So it's pretty big. And we do have plans to make the ship and booster even taller in the future, if you can imagine.
And Starship itself features 2 major parts. We've got ship, that's the fully reusable upper stage powered by 6 Raptor engines. And then we have the Super Heavy booster that's fully reusable first stage with 33 of those Raptor engines powering it. Super Heavy, the most powerful rocket ever flown. It's designed to launch, return, refuel, launch again with 0 refurb. And to make all of that happen, we also have Stage 0. That's everything else you see around it that enables Starship to fly. The tower, the orbital launch mount, quick disconnects, prop farm, everything. Stage 0 is also just as critical to achieving that rapid reuse as Starship itself.
Back on the rocket, the ship features 6 Raptors, 3 of them for sea-level engines and 3 for vacuum engines. Raptor Vacuum, or RVAC, is a similar design to the Raptor engine, but features a larger exhaust section and a larger expansion nozzle to maximize the engine's efficiency in space. It's also designed for vertical takeoff and landing on any hard surface, useful for when you're taking off from a place like Mars that's still waiting for its first launch tower.
And that ship is outfitted with 4 flaps that are used to control the vehicle's attitude during subsonic flight and to enable a precision landing. The 2 upper ones are right here. And then to achieve full reusability, the ship has to survive entry not just once, but multiple times every single time we send it up and bring it back. It does that with its heat shield, which we iterate on every single flight as we're just building towards a heat shield that requires no refurbishment. The one today, it's still composed of those thousands of hexagonal ceramic tiles, and they're designed to insulate the vehicle during that atmospheric reentry where some of those temperatures spike up as high as about 2,600 degrees Fahrenheit. That's one of the real big things we're still working on. Rapidly reusable heat shield has never existed in history, so just continuously improving on it right now is just a key focus for all of these flight tests.
And then there in between the first and second stages is our hot stage. We saw that in action first starting on Flight 2. The hot staging maneuver is when the upper stage engines are ignited before the booster engines are completely cut off. With hot staging, the rocket never stops accelerating during separation. So it's actually more efficient than traditional stage separation, even though it sounds kind of crazy. You actually see it there on your screen now. That is one of the upgrades that we made on Flight 2, thanks to lessons that we learned on Flight 1. Several of the improvements and upgrades made for today's flight will unlock our ability to fly longer missions, something that we'll want to start doing, as we start doing orbital flights around Earth, and of course, eventually to Mars.
And ship definitely had a lot of lessons learned on Flight 7, but Super Heavy Booster put on one hell of a show for our second ever return to launch site and catch. Marked our first reflight of hardware, shout out Engine 314, and it brought us a lot closer to full reuse. For more on that, get ready, Internet. We're going to be joined now by our buddy Chris out in Hawthorne. How's it going, Chris?
And thank you, Dan, and I couldn't agree more. Raptor 134 definitely started us down that path toward rapid reusability for the Raptor engines, and who knows, maybe we'll see it again. Stay tuned. Welcome everyone to Hawthorne, California. As you can hear, excitement is building as we count down to Starship's 8th flight test. Behind me, you can see one of our mission control rooms where engineers here in Hawthorne are assisting our flight control teams in Starbase, keeping an eye on various systems like Starship's avionics and, of course, those powerful Raptor engines that have quite a workout ahead of them today. Now, the Raptor engines you'll see and definitely hear today were manufactured right here in Hawthorne, California. And the engines on today's flight are all Raptor 2 engines, which is the same design we've been using for Starship's flight tests to date. And that includes all of the engines that have powered the 2 Super Heavy boosters back to Starbase for catch and recovery by Mechazilla. But here at SpaceX, we like to continuously improve our designs by eliminating the parts we don't need. We call this applying the algorithm, and that helps us simplify designs and drives us toward rapid, reliable reuse. And that's just what we're doing with our Raptor engines, like you can see here on your screen. I love this family photo of the Raptors because it really shows you the unprecedented step forward in rocket design that Raptor 3 is. And you can really tell that we applied the algorithm here, questioning the requirements for the engine, finding the parts we didn't need, and then optimizing for manufacturability and reuse. Now, one of the cool things about Raptor 3 is that it eliminates the large and heavy engine heat shields, which means that when we move from the Raptor 2 to the Raptor 3 engines on Starship, each Raptor 3 engine is going to save us about 1.1 metric tons of mass, and that's a lot of mass when you multiply that by 39 or more engines. So Raptor 3 will help us increase Starship's efficiency and as well as the amount of mass that Starship is able to deliver to space. And I gotta say personally, it's really exciting to be looking at the engine that will make life multiplanetary, beginning with Mars. But before we get to Mars, we still have a lot of important and critical development work to do. And it's flight tests like today's that help us do just that. So as we get ready for Flight 8, let's take a look back at last month's Flight 7.
Flight directors, go for launch. T-minus 5, 4, 3, 2, 1. We have one.
Agora que você mandou aqui no tweet dela agora há pouco. Opa, Pedro, estou assistindo com a minha mãe pela TV, ela disse, ai, que homem bonito, referindo a você, olha só. Mais uma pessoa que me acha bonito sem ser a minha mãe, a minha esposa, agora sua mãe, vem atrás para sua mãe. Vai botar live desse SpaceX? Ô, Tanqueta sabe para você muito bem, já temos imagens sobre
Vehicles, pitching down approach. Max Q. Booster engine cut off. Stage separation. Goose prep for startup.
launch team is go for tower catch.
We are go for booster return. Looks like we have lost a ship.
Oh man, seeing that recap, my hands got sweaty again in excitement watching that and in anticipation knowing that we're going to hopefully get to experience booster catch again. I know seeing my first booster catch, I'll never forget.
There's nothing like it.
Yeah.
Nothing on the planet.
Now, using the data from Flight 7, we've made some key improvements under the hood for today. Flight 7 taught us a couple of important things that changed some of our pre-flight testing to help us investigate more. First, we saw a harmonic response several times stronger in flight than we saw in testing.
And harmonic response, in this case, it's essentially vibrations that we're seeing go through the structure. Rocket engines, as you can imagine, create an incredible amount of noise and vibration, which then passes through every component of that rocket. And on Flight 7, we saw those vibrations happening at a very specific frequency, and they were placing some extra stress on that hardware in Starship's propulsion system. This is most likely what led to propellant leaks that we saw that eventually cascaded into fires and ultimately ended with loss of contact with the ship.
As part of our investigation, our team at Starbase took this flight's ship through a 60-second static fire on the Starship test stand, which is 10 times longer than any previous static fire. During this test, we cycled through multiple throttle levels. In fact, you can see that on your screen now. We cycled through multiple throttle levels on the engines to recreate different conditions seen within the propulsion system during flight. And we tested some hardware changes on fuel feed lines to the Raptor vacuum engines.
This gave us just the extra data that we needed to eventually implement new hardware that's installed in those fuel feed lines for the RVAC, the Raptor vacuum engines. Also tweaked a couple of other things like the temperature of the propellant as we're feeding it to the engines. Also the throttle level that we set for those engines during ascent. Having the ability to do a 60-second static fire, just one of the ways we're trying to expand our test capabilities here at Starbase. You want to test like you fly as much as possible. That just helps us to iterate even faster.
Yeah, exactly. The fuel feed lines to the Raptor vacuum engines, which are unique to this upgraded version of ship, look like large straws running through the oxygen tank. Today's vehicle has one of the hardware configurations we tested in that extended static fire because it showed it was able to minimize the harmonic response and lower its amplitude or strength.
We also took another look at where those fires broke out, specifically in what we call the attic. That's an unpressurized space between just the bottom of the ship's liquid oxygen tank and the top of those engine heat shields. Fires in that space resulted in a loss of vehicle back on Flight 2 and also on Flight 7. So we took some steps to make it more resilient to leaks in the future. To do that, we added a pretty hefty purge system. It's going to use gaseous nitrogen. It's pretty similar to the CO2, the carbon dioxide system we use on booster. It essentially just floods the zone with an inert gas to prevent a fire from ever starting. And then in addition to this, we increased the attic's natural fire defense just by adding some additional vent holes. That helps to keep the attic pressure as close to just vacuum as humanly possible as Starship flies into space.
And for the next generation of ship, we're running the algorithm. We're going to try and do the next best possible thing and delete some of the unnecessary space. So that ship will be using Raptor 3 engines, which will let us reduce the attic volume and eliminate the majority of joints that can leak into the space. In the end, what you're seeing take place with these changes is the core of our test program. We fly hardware all together in a real-world environment. We learn from the data, we make upgrades, and then we fly again. Ultimately, we fly to learn, and we're learning a lot.
That's right. Now, for today's flight test, we're going to be attempting to do everything we didn't get to do on Flight 7. We're still looking to get our first re-entry with this upgraded version of ship. Also intentionally trying to stress it to gather real-world data on just where the vehicle's boundaries are. So don't be surprised if it's not a smooth flight down to a landing for ship today. As always, it's going to start with liftoff, the 33 Raptor engines on super heavy igniting, lifting both it and Starship into its ascent, and it's going to power us all the way until hot staging.
Yeah, those engines on the ship will ignite while the ship is still attached to the booster. This will create that stage separation that we see there. Second stage will continue to go on its way. The booster will make a flip and come back here to the launch tower just behind Dan and I for hopefully what we will see the third ever booster catch.
Meanwhile, ship continues its ascent, gets into its suborbital place in space. We're going to have a test satellite deploy, pew pew, Starlink's firing out. And then we're also going to do a Raptor relighting one of those sea level engines before we get to ship re-entry.
Troubleshoot by the state machine.
And the ship will continue through, make its entry phase that lasts for a few minutes.
And if some comms did just go out, we heard that an operator hold got in, so they are troubleshooting one issue. As we continue to move through prop load, we'll get some more details on what caused the hold, and if we start to reset to a new T0. We are still loading prop on the vehicle, so essentially putting that hold in means that if we get through everything and we hit that T-minus 40-second mark, we'll hold there and wait to clear the issue if we haven't cleared it at some point in the next 20 minutes.
Yeah, for those that are unfamiliar, that T-minus 40-second period is an opportunity to troubleshoot, unlike our Falcon timeline. So we do have a little bit of leeway. Yeah. Continuing on with today's plan, that ship will be making a soft splashdown in the Indian Ocean, as we have seen before. We are launching at 5:45 p.m. Today. This evening launch will allow us to have daytime views of the ship as it makes its splashdown. So, yeah, good news.
It's a lot on ship's plate, but we're still hyper-focused on finding all of those real-world limits of Starship. We want to be able to prepare to return ship to launch site and catch it. A lot of these recent upgrades are just made to enable that to actually happen.
Flight 7 premiered a huge block of upgrades to the upper stage to add more capability to Starship. And with Flight 8 today, we're hoping to get through a full flight. Starting us off, the forward flaps got a redesign. They shrunk in size and shifted toward the top of the vehicle and away from the heat shield. And that will significantly reduce their exposure to re-entry heating. Also, by making Starship 2 meters taller, we added about 25% more propellant volume, along with propulsion upgrades such as vacuum jacketing of the feed lines, new fuel feed line system for Raptor vacuum engines, and an improved propulsion avionics module.
Yeah, ship got a little bit taller. That extra prop's going to allow us to fly those longer missions. We're not planning on stretching it a whole lot more beyond this in future ones, but then, you know, once we're flying the next version a lot, it'll be going. Just like the previous flight, a lot of tiles have been purposely removed. Again, we're trying to stress test all of the vulnerable areas, call this the missing tile test. Those tiles are removed in strategic locations all across the vehicle, including critical areas like those tanks and over the flap seals as we use this flight to just really push those boundaries. In addition to that, we have some metallic tiles, again, that are being tested, including one on the right of this animation that has some active cooling built in.
The vehicle's avionics also underwent a complete redesign with things like 4 upgraded Starlink terminals, combining Starlink, global navigation, and RF communications. You can see that location there on your screen. And on the sides of the vehicle, non-structural versions of the ship's catch fittings are installed to test the thermal performance, along with a smoothed and tapered edge on one section of the tile line to address hotspots that we observed during Flight 6.
And once more, we're back at testing some radar sensors on those tower catch arms. We did that last flight, We're doing it again as we look for some additional ways to measure the distance between the arms and the vehicle. Catching the ship's going to be pretty different from catching the booster. It does that flip right before, so your antennas are going to rapidly reorient. And so just having any extra sensors on the ground side, you're adding extra layers of control while the ship and tower talk to each other for a catch.
In another first, Starship will deploy 4 Starlink simulators. They are similar in size to our next generation Starlink satellites. With unparalleled payload capacity and full reusability, Starship will be able to deploy our more advanced V3 Starlink satellites, which will revolutionize global connectivity with Starlink all over again.
Each one of those Starlink V3 launches on a Starship is going to add about 60 terabits of capacity to the Starlink network. To give you some context, that's about 20 times the capacity of what we're adding with every V2 mini launch and a Falcon 9 right now. That's going to help us expand Starlink's network, expand its impact in the coming years as we expand that access to high-speed internet all around the world and eventually beyond. And the Starlink simulators that we're deploying today, they're going to be on the same suborbital trajectory as Starship. We expect them to demise as they enter in the atmosphere. And then Starship's trajectory itself looks very similar to our last several flights, splashdowns targeted in the Indian Ocean. And on top of all of that, we're also going to relight a single Raptor engine again while in space. We're just trying to get data on in-space Raptor burns. You're going to need those for deorbit burns when we're doing orbital missions, and eventually when we're doing missions way beyond Earth and we're on our way to Mars.
Yeah, so just like you said earlier, Dan, there's a lot on Starship's plate for today. But one of the hallmarks of these Starship flights are the incredible views that we get throughout the flight, courtesy of Starlink. Every day, we're working to expand the Starlink network both on Earth and in space. For how all this connects us to the big mission, let's head back to Chris.
Thanks, Kate. And as fans of Starship may know that Starlink enables us to bring you a lot of those unprecedented views, both from space and on Earth. Personally, I love all those epic views of the plasma wrapping around Starship during re-entry. So thank you to our Starlink teams who enable all of those amazing views and the information we get. Now, in addition to the dozens of cameras on Starship itself, as you see on your screen here, we also have mobile Starlink camera kits deployed in the middle of the Indian Ocean, as you're seeing from a previous flight. Starlink also allows us to connect our aerial cinematography units on the ground at Starbase and at other strategic camera spots around Texas and the world. And that's all part of how it comes together to help us tell the incredible story of Starship, both on and off the planet. So thanks to Starlink, Starship is now capable of streaming more than 120 megabits per second of real-time, high-definition video and telemetry through every phase of flight. This not only provides those incredible views of re-entry for all of us, but also the invaluable engineering data to help our engineers rapidly iterate across all systems of Starship. And all of that streaming data today will be put to good use with the more than 30 cameras that are on the vehicle for today's flight. Now, Starlink is the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people around the world, many of whom have never had connectivity before. As of today, Starlink is serving more than 125 countries, territories, and other markets, and has more than 5 million active customers and counting. But to meet the growing global demand for high-speed internet, SpaceX recently expanded its factory at Bastrop, Texas, and introduced Starlink Mini as well as an upgraded version of the Starlink standard kit. Here's our first ever look inside our brand new Bastrop facility.
There's like an interesting stat where like the odds of being struck by lightning in your lifetime are like about 1 in 15,000. And we make 15,000 dishes a day. If the odds of a defect happening are the same odds as being struck by lightning in your lifetime, it's almost guaranteed to happen one time in this factory a day. So you have to have like a very intense focus on quality.
Right now, we're in Bastrop, Texas at the Starlink manufacturing site, just about 20 miles east of downtown Austin. So the main function of this site is to produce our standard Starlink kits. Right now, we're producing 15,000 a day straight out of the factory. Raw plastic pellets come in, raw aluminum comes in, and we make those into the Starlink kits and then ship them right out to customers' homes.
When you manufacture the product that you design in-house, you're forced to live with the mistakes. What that means is that you're very motivated to quickly innovate and iterate such that you can rapidly improve the process. Our previous generation of the production line was maxed out in terms of capability, and the demand for Starlink has kept growing. So when we sat down to go design this factory and this version of our production line, we were really forcing ourselves to innovate. The future of this factory is growth. We're in the middle right now of constructing an expansion to our current factory. We're going to add over 1 million square feet of manufacturing space over the course of this year and allow us to continue to insource more of our manufacturing processes so we can continue to go from raw material to completed kit within the walls of this factory. I can't understate the hard work of all the employees at this factory who've made this a reality. Less than 2 years ago, this was an empty building with no employees. And over the last 20 months, we've built a factory from scratch. We've gone from producing 0 kits to over 70,000 a week. And we've gone from 0 employees to over 1,000.
And it is incredible to see all of the tech in that facility that will help millions of people around the world the way they want to use it and the way that they need to use that technology. Definitely a lot of good things to come from our Bastrop facility. And while we're talking about the infrastructure that enables us to do all of these amazing things, you've probably seen some changes recently around Starbase. Coming online this year is the second tower at Starbase, and this tower has redesigned chopsticks and is built to accommodate the next generation of Starship and Super Heavy. It will have a redesigned launch mount and flame diverter system built to be rapidly reusable and hardy enough to withstand hundreds of launches at a time. Now, over at the production site down the road, we're also building a new integration and refurbishment facility called Gigabay. And Gigabay, as the name implies, will allow us to process more Starships at the same time over our current Megabays. But Gigabay isn't just for Texas. If that weren't exciting enough, we're also further expanding Starship operations into Florida, bringing production and launch capabilities to the Space Coast. As Starship flight testing, development, and launch cadence continues to pick up pace at Starbase in Texas, over in Florida, we're building a Gigabay as well. Gigabay will stand 380 feet tall and will provide about 46.5 million cubic feet of interior processing space and about 815,000 square feet of workspace. Now, as environmental impact statements continue for potential Starship launches and flights from both Launch Complex 39A at Kennedy Space Center and Launch Complex 37 at Cape Canaveral Space Force Station, we plan to complete the Starship launch pad at Pad 39A this year. And pending the completion of environmental reviews, SpaceX intends to conduct the first Starship launch from Florida from Launch Pad 39A later this year. Now, we're also interested in enabling Starship launches from Slick 37. And as part of this process, SpaceX has been given a limited right of entry for Pad 37 to conduct further due diligence at the site in order to move forward with the environmental impact study that's being led by the Department of the Air Force. Ultimately, we will have production, integration, refurbishment, and launch facilities in both Florida and Texas, driving the needed flight rate for Starship to help make humanity a multiplanetary civilization. And Kate, I could talk about this stuff for literally hours on end, but we've got a Starship to launch today. So how are things looking 11 minutes before launch here?
Yeah, it's pretty cool that we're getting close to go time. Quick update on range and weather. For the range, the area around the pad has been well cleared. This includes the land, air, and sea space. So all is clear on the range front. That also applies to over in the Indian Ocean. The sea and airspace has been cleared as well for ships re-entry. Once again, we are making a soft splashdown in the Indian Ocean. So just the buoy cams are out there, and we'll get some great videos once again. Weather, we have a 35% chance of violating the weather the weather constraints for launch today. So it's not perfect, but it's not bad. Visibility also not so awesome. We can see the tower here. We're 2 miles away from the launch pad, but visibility around the greater area might be a little challenging.
Yeah. In terms of the vehicle itself, so right now you can see we're almost done loading prop on ship, almost done on booster. If you tuned in and heard earlier, we did hear talk about a flight controller hold going in. So just a reminder, all that means is we wouldn't be able to pass that T-minus 40-second mark. They're literally talking about it right now on the loops that they think they've got the problem figured out. It was an issue on the booster where we think we will be clear by about the T-minus 2-minute mark, and we will be able to move right through that T-minus 40, hopefully. So prop load continuing. We're not holding or anything yet. And we're expecting that issue to clear before we get to that T-minus 40 mark. This morning, though, we did all of the usual checkouts, aligned the navigation systems, did all of our booster and ship tank purges, got them ready for prop load, chilled down the pad, which you can see all the cryo right now. Things are pretty chilly out there. Prop load's been going. We just did a flap check out. We also do a wiggle check out on the chopstick arms as well. We are going to continue loading prop for about another 6 minutes. We're going to close ship at about 3 minutes, 20 seconds before launch. Booster just about 30 seconds later. So we've had at least one issue that we're still working in the background, expecting that to clear before we hit that hold gate at T-minus 40 seconds. And looking good.
Yeah, so bottom line, things are looking good for liftoff here in just under 9 minutes. We're now at, looks like 8 minutes and 49 seconds. So everything's looking green so far.
Yeah. Before we get any closer to liftoff, I need to shamelessly plug Starbase. I'm one of just a couple thousand people who work here. Soon to be the newest city in Texas at Starbase. And we're the largest employer in the area. We're always hiring. So visit spacex.com/careers, see all the openings. Where the future's being built, and it's a future we can all be pretty excited about. So yeah, come work here. Anyway, back to our regularly scheduled program. Let's launch a rocket.
All right, so we're coming up to 8 minutes until liftoff. As we mentioned before, flight controllers are already on console. They're located in our Ad Astra Launch Control Center, about 6 miles away from the pad. But they will soon be moving here with us to Star Factory. So a lot of excitement around that. Certainly growing.
Yeah, and again, general status check. We're continuing to progress. We're under 8 minutes away. We're tracking an issue with booster. We're expecting that to clear. Still looking good for launch. Speaking of booster, let's talk about catch and launch. The tower's 2 giant robotic arms that lift and stack Starship on a super heavy for final integration ahead of flight. We also use those to catch. Means we don't have any landing legs in the booster. Makes the booster lighter. Means we can throw more payload into space.
Exactly. Following liftoff, and after the 2 stages separate in flight, Super Heavy will return to the launch site, the same exact launch site that it lifted off from, reignite its engines to slow the vehicle down. Here we see playback from a previous booster catch. I believe that was our first booster catch. The vehicle will slow down, tower arms will come out and catch the booster.
And just like the last few times, literally thousands of different vehicle pad criteria have to be met before we bring a booster back and try to catch it. We need healthy systems on Super Heavy, on the launch tower, and we need that final manual command from the mission's flight director for the day. If that command isn't sent before we finish the boost back burn, or if any of those automated health checks kick us out, the booster defaults to a trajectory, takes it to a landing burn and a soft splashdown in the Gulf.
Yeah, we have said it multiple times before, but it still holds true today. We accept no compromises when it comes to ensuring the safety of the public and our team, and the return will only take place if the conditions are right, and there are many of them. So there's a chance that we may not get to catch the booster today.
Yeah, and one aspect of the return and the catch of that booster is the audible sonic boom in the area around the return location. That happens as the booster's slowing down from supersonic speeds. It's similar to sonic booms that were heard during the return and landing of NASA's space shuttle for anyone that was in Florida for those.
Sonic booms like these are unique to vehicles returning from space and are one of the hallmarks of reusable systems like our Falcon 9 and Falcon Heavy vehicles. The general impact to those in the surrounding area of a sonic boom is basically a brief thunder-like noise. And I've heard sonic booms before, but I got to experience my first in-person Starship sonic boom on Flight 7. And I can confirm it's pretty fun to experience.
Aparentemente eles vão segurar até T2 em relação para tentar resolver problema em boster, que tá dando BOzinho.
And as someone who has heard sonic booms
não.
many times in Florida, they are definitely a hallmark, and what a way to announce a returning space vehicle's return for reuse. Now, here in California, as you can imagine, the excitement is growing here, the crowd is growing. Kate mentioned our flight controllers in Ad Astra in Texas. Here in Hawthorne, we also have controllers on console in Mission Control, helping those teams in Texas monitor Starship's various systems, including the avionics and those 39 Raptor engines that were built right here in Hawthorne. Now, with 4 minutes, 30 seconds to go, Dan and Kate, how are we looking for a launch today?
So we are still looking good. We're just about fully topped out on propellant. On both vehicles. The closeout's going to be coming up in about a minute on ship, and then about 30 seconds later on the booster. We are still hearing chatter in the background about the booster issue that we're tracking.
Beleza, estão ouvindo. Ok. Opa, galera, bem-vindo a uma outra live. Aqui estamos vendo o oitavo voo da Starship. E falta mais ou menos 4 minutos para acontecer. E se acomodem e vamos ver esse lançamento. Então sou eu falando agora porque o microfone do Chiquitinho tá bugado e aí ele já volta, só tá tentando arrumar o microfone dele.
Now, in the next few minutes, the guidance system will perform a final alignment.
Oh, meu Deus, Senhor, me ajuda.
Me
ajuda, papai querido. Faz funcionar.
10 minutos.
12 pessoas estão assistindo, calma, pessoal. Pera, fala pra ele seguir a gente, mandar contribuição, mandar presentinho pra cada um aqui, inclusive.
Qual a missão de hoje? É o oitavo voo da Starship. A missão é o booster, todo o foguete subir, o booster voltar para a torre e pousar, a Starship lançar 4 satélites da Starlink e fazer uma reentrada na atmosfera, no Oceano Índico. Sigam a live e mandem para seus amigos para aumentar o número de espectadores na live. Ah, e deixem um like também na live. Vai ajudar bastante.
Coloquem na televisão e no celular para ajudar.
Sim.
Cara, mano, meu áudio não quer
Se vocês estão se perguntando quem é a gente é os ADMs do servidor do SpaceNet BR, que inclusive vocês deveriam entrar, para quem não tá ainda no servidor, que está o link está no perfil do Chiquitinho, só vocês entrarem lá.
Galera, fala que eu tô no YouTube, que meu
YouTube no momento está em uma pausa para atualizações e melhorias. Esse RT é exclusivamente sobre o Flight Simulator. Perdão, o Nixon tá foda. Mas
alô?
Vocês que jogam e acompanham por esse motivo vão provavelmente...
Aí, tá funcionando! E aí, galera, bem-vindos a mais uma live. Hoje estamos aqui para acompanhar mais uma live aqui do canal. Perdão aí, galera, nossos ADMs aí. Muito obrigado aí, ADM. A gente tava ajudando aí a fazer a live, mas graças a Deus deu tudo certo. Consegui meu áudio, graças a Deus. Nosso áudio deu certo, galera. Faltam 1 minuto para o lançamento. Então compartilha essa live e deixe a sua curtida. Estamos com 59 pessoas assistindo. Manda essa live, vamos chegar a 100 pessoas que vamos acompanhar o lançamento do maior foguete do mundo. Na verdade, ADM, segura aí!
Vamos! Não posso gritar.
Fala aí, galera, vamos lá! O Tom falou é tripulado, não é carga. Vamos lá, galera! O Shinra... 1 minuto! Menos de 1 minuto! Shinra começou a seguir, a gente salve pra você. DEIXE começou a seguir a gente. Vamos tentar chegar a 100 pessoas na live, galera! Compartilha aí, vai ser o maior foguete do mundo! E mandem contribuições! O Marlon mandou um presentinho, tu segura a contribuição dele! Segura aí! Ô Steph, compartilha lá no Discord também.
Deu hold em 40 segundos.
Aí o Biel e o Brasil também enviaram contribuições, deu hold, mas conseguimos 100 pessoas, segura aí!
E deem like também na live. E entre no servidor do Discord do SpaceNet BR. O link está no perfil do da live, perfil da live.
Isso aí! Vamos lá, galera, também temos o nosso servidor no Discord. Contribua lá, vamos lá, que tá muito legal pra gente ter mais lives como essa e lançamentos do mundo espacial. Também tem o nosso RP do Discord. Tudo isso está na bio do perfil também. E o user também enviou uma rosinha, tu segura a contribuição dele.
Ainda está no momento
hold.
Estamos no hold, aparentemente a DEIXE está com problemas no booster que devem tentar resolver para o lançamento. Caso contrário, imagino que tenha um explosão.
Isso aí. Vamos lá! Tá chegando a hora, 40 segundos de hold, daqui a pouco eles vão soltar, então segura aí. Compartilha essa live e deixem a sua curtida, que estamos acompanhando o lançamento do maior foguete do mundo, beleza? O EW mandou uma rosinha, então segura a contribuição dele.
Salve para todo mundo que está pedindo live e falta ainda 40 segundos. Será que não vai acabar esse hold não? Ave Maria.
Sei lá, vamos ver se vai liberar. O Marlon começou a seguir, gente, salve pra você. O Santos compartilhou a live também, salve pra você. O Biel Stone falou, falta quanto para o lançamento? Faltam 40 segundos para o lançamento, mas o cronômetro está em hold, tá? Vamos ver até quando que eles vão liberar, parece que em cerca de 1 minuto, pelo que eu saiba, beleza? O Davi falou, onde você achou essa câmera? É a SpaceX que está transmitindo no Twitter, mas estamos transmitindo aqui pra vocês no TikTok, então deixa a sua curtida. E se você não segue a gente, aproveita e segue pra ter mais lives como essa, beleza, galera? Então siga aí, o user começou a seguir a gente. Oi?
E entre no servidor do Discord do SpaceNet, tá no perfil do Discord, do TikTok.
É isso aí, vamos lá! Vamos lá, nossos staffs aí dando a voz aí pela primeira vez na transmissão. O Márcio enviou uma contribuição, então segura aí.
Vamos, galera, dê like na live. Vamos esquecer esse número de likes na live.
Isso aí, estamos com quantas curtidas, o staff da PVI?
Está com mais ou menos, deixa eu ver aqui, 5.000 já curtidas.
Bora lá, galera, contribuem aí, mandem a sua curtida e deixem a sua e segue a gente pra ter mais lives como essa, como o Joselino Tavares e o Lucas Vichy também começou a seguir a gente. Salve para todos vocês. Beleza? Então vamos compartilhar essa live. Lembrando, galera, que temos o nosso servidor no Discord, beleza? Entre no nosso servidor no Discord, nós também estamos em call aí pra galera toda aí que tá no nosso Discord. A gente abriu um canal aí, o pessoal tá falando aí, deve tá me xingando, deve tá me falando um monte de coisa sobre mim.
Não, todo mundo te ama.
A gente tá em hold em 40 segundos, daqui a mais ou menos 1 minuto, e provavelmente vai descer o countdown.
Isso aí, vamos lá!
O Fernando Rossi, o lançamento é em Starbase, no fim do Texas, no sul do Texas, na fronteira com o México.
Isso aí, vamos lá! Bora lá! Oi?
Daniel, por favor, me permita falar um momento?
Sim, claro, fala!
O Tyler, ele no momento está em um dos nossos estados do Tyler, no momento está indisponível. Os testes não foram explicados, mas saibam que existe.
Isso aí. Ô, cara, dá pra melhorar um pouco, sim, um pouquinho o seu áudio, que tá meio ruidinho.
Então, não entendi nada.
O G-Steam começou a seguir a gente, salve pra você. Muito bem, meu Deus, velho, quando que vai liberar esse hold, cara? Libera! Será que o Eric Tariga falou, será que dá pra eu comprar um foguete desse? Ah, sei não, conversa com o Elon Musk aí. O Gessimo enviou um sorvetinho, então vai ter a contribuição dele, segura aí! Vamos lá, deixem a sua curtida, hein? E segue a gente pra ter mais lives como essa. Em breve vai ter o lançamento do Starship, beleza? Que é o maior foguete do mundo. Está eu e mais a nossa galera, a nossa equipe ali do Discord. Estamos aqui para acompanhar juntos o lançamento do maior foguete do mundo, que é o Starship. Que algum staff aí pode me dizer quais são os 2 veículos que vão voar hoje? Alô? Deu ruim ali. Deu ruim. Pera aí. O que aconteceu? Galera, nossos staffs saiu aqui. Alô? Alguém aí? Mano, eu não tô ouvindo ninguém.
Alô, tem.
Aí, foi. Eu achei que tava sozinho aqui.
O hold foi retirado, 30 segundos.
Tirou? Cadê? 41 segundos, hein? Vamos ver.
Voltou para 41.
Oh meu Deus do céu. O Gest me enviou uma rosa também. Segura a contribuição dele.
O hold voltou. Está de volta, tem menos 41 segundos.
Vamos lá, galera. Você está acompanhando o lançamento do Foguete Starship, que é o maior foguete do mundo, que é cerca de 123 metros de altura, beleza? Se não o maior foguete do mundo, e está na sua tela aí pra vocês, beleza? Então compartilha essa live, mandem bastante contribuição aí pra tocar musiquinha exclusiva pra ajudar a gente aqui, beleza? Yurizinho, o Gesto me enviou mais uma rosa, então segura a contribuição deles. Voltou pra 40 segundos. Eita. Quantos metros tem mais ou menos? Ô Davi, tem cerca de 123, né gente?
123, 71 do booster e 53 no segundo estágio.
Isso aí, muito bem! Valeu aí pela informação. É só nessa live que você encontra essas informações oficiais aqui e verdadeiras, beleza? Então vamos lá, o Jonathan Lonardi começou o seguinte, salve pra você. Vamos lá, imagens ali de drone, bela tomada, olha só, mano. Tu lembra de mim? Eu era o Lorocket Agência, era a minha conta de IFT. Cara, não lembro, infelizmente. Perdão aí. Perdão. É muita gente, galera. Eu não consigo lembrar de todo mundo. Principalmente se for 2022, era meio esquisito. Vamos lá, 14 mil curtidas, vamos lá. Tá chegando a hora. Essa SpaceX não libera esse hold desgramado. Mas você está acompanhando aqui.
Scrub, lançamento foi adiado pelo dia.
Scrub?
Ah, não é possível.
Scrub? Não. Mentira.
A Starship vai ser descarregada e vão tentar outro dia. Scrub.
Ah, não!
E a ansiedade tá aqui como?
Que
ansiedade.
Ah, não. Ó, mas olha só. Foi uma boa live de hoje. Estamos com... Essa live já deu mais de 500 visualizações. Muito obrigado a você que compartilhou a live. Será que dá pra gente continuar batendo um papinho aqui, assim, né? Vamos ver qual dia será... Será que já informaram qual dia que vai ser o próximo lançamento?
Provavelmente amanhã.
Amanhã? O mesmo horário, será?
Deve ser.
O Davi falou qual destino, era uma órbita, uma trajetória suborbital, beleza?
Pera aí, eu vou tentar deixar a informação.
Beleza, procura a informação. Luiz Felipe Espindola começou a seguir a gente, salve pra você, muito bem. E acabou a live da SpaceX. Oh, beleza, muito bem, que bosta.
Oh, caramba. E a ansiedade aqui gigantesca pra nada.
Que bosta. Ai, mano, mas... Pô, velho. Então, galera, acesse o nosso grupo do Discord, o link está na bio do perfil, beleza? Lembrando que também a gente tá ao vivo no nosso servidor no Discord, no YouTube, beleza? E aqui no TikTok também, tá? Então é isso, galera. Muito obrigado a você que assistiu até aqui.
Só pra falar.
Opa, fala aí. À vontade.
Meu áudio tá ok?
Tá ok, agora tá assim.
Bem, a SpaceX ainda não confirmou a provável data do lançamento, mas eu imagino que tenhamos essas informações em breve.
Isso aí, vamos lá.
A gente não pode esquecer que acabou de dar scrub, até eles falar alguma coisa vai demorar pelo menos uma hora. Uma hora ou duas.
Então. Juan Duarte, é isso aí, galera. Não foi desta vez, beleza? Mas a SpaceX ainda não divulgou o motivo da... Acho que é por causa do tempo, né? Muito vento. Será? Eu acho que é. Mas, enfim, galera. A gente...
O clima também não é
então. O clima não tava ajudando muito.
Eles poderiam lançar, já lançaram com muita neblina também.
Então.
Tem algum problema com isso. Estavam fazendo algumas verificações.
Pois é. Mas é isso, galera. Muito obrigado a você que compartilhou a live, que ficaram até o final, beleza? Lembrando que acesse o nosso servidor no Discord ou o nosso servidor no Discord e no canal no TikTok e no YouTube para ficar mais informado sobre o mundo dos lançamentos espaciais. Beleza? Lembrando que também a gente tem um RP lá no Discord sobre Space Flight Simulator, bem da hora. Então vá lá e faça parte desse game muito legal, beleza? A gente também tem uma equipe de ADMs que montaram esse RP, beleza? Então vamos lá, que tá bem legal o trabalho da galera. Beleza? Então é isso. Tem alguém pra falar aí? Últimas palavras?
Uma coisa eu posso dizer.
Fala aí.
A chip não vai dar mais scrub que a Starliner.
Isso você pode falar mesmo. Mas é isso, galera. Dá um tchau aí, galera do ADM. Fala aí. Falou. Se despeçam aí.
Falou. Tchau, John.
É isso aí, galera. Mas eu vou ficando por aqui. E até a próxima. E falou!
Adeus. Pelo menos. Ele já encerrou a live ou a gente ainda tá falando só? Falou.